Hi guys, this is Mr. Urrego, and I'm going to go over a couple of trigonometric equations. We're going to solve them. So we're going to solve, let's say we're going to solve, let's get a pencil here. We're going to solve sine square of x plus minus 1/2 equals 0. I got to solve for the value of x, which is my angle, and the range for my angle is between 0 and 2 pi. That means my answer have to be in pi radians. Sorry, that's a pi. All right. So first things first, I got to solve for sine of x. I got to leave the sine of x by itself. So I got to cancel 1/2 plus 1/2 on both sides. Okay, this cancels, and I have sine of x, sine square of x equals to 1/2. I need the sine by itself, not squared. So that means I got to do the square root on both sides. Okay, as soon as I do square root on both sides, what's going to happen is, in this side, on the right side, I'll need to have a positive negative. Okay, and that's going to give me square root of 1/2. That square root of 1/2, I can break it into 2. So I have plus or minus square root of 1 over square root of 2. The square root of 1 turns into 1. And the square root of 2 stays as the square root of 2. Can I have a radical in the denominator? No, you cannot. So I have to rationalize, which means I have to multiply by the same radical. Okay, and that's going to give me a square root of 2 on the top, and 2 times 2 is going to give me square root of 4. The whole idea about the rationalizing is, so now square root of 4 is equal to 2. So I have a plus or minus square root of 2 on the top and a 2 on the bottom. So sine of x is this, plus or minus square root of 2 over 2. So from here, I get two answers, one positive, one negative. Okay, so my first answer is going to be sine of x equals a positive square root 2 over 2 and a negative square root 2 over 2. All right, having this, then I go to my unit circle or to my triangles. Well, the whole idea is, what's the angle x where the sine is equal to square root 2 over 2? If I go back to in our case, this is going to be a 45 degree angle, 45, 90. The sides are square root 2 over 2 and square root 2 over 2. And remember, hypotenuse is 1 because we're talking about the unit circle. Okay, so where's my sine going to be positive square root 2 over 2? Then I go to my unit circle. Okay, and I see it here. All right, square root 2 over 2, my sine is the y value. So here we go. So I have that at pi over 4. So my sine is positive in Q1, which is square root 2 over 2, and Q2, which is going to give me 3 pi over 4. So my first angle for this one is x equals this angle in terms of pi is pi over 4. 45 degrees is pi over 4, so that's my first answer. Okay, and this is in Q1. If we notice, we have the answer as well in Q2, which is going to be, look, square root 2 over 2 for my sine. Remember, is the y value. Your y is your sine, the x is your cosine. So square root 2 over 2, 3 pi over 4. And this is going to be in Q2. So those are my answers for my positive. What about my negative? Square root 2 over 2. So I gotta go the same. My reference angle is 45, which is pi over 4. That's my reference angle. So I come over here and I look at my third quadrant and my fourth quadrant. Okay, my sine is negative. Why? Because it's going down. So here we go. Negative square root 2 over 2 is going to be 5 pi over 4, and at 7 pi over 4. Okay, so those are my two answers with my negative. So here is going to be 5 pi over 4 and 7 pi over 4. And that's my answer for this problem. Okay, let's work on one more. So let's work a little bit more, something more complicated. So we have 2 sine square of x plus sine of x minus 1 equals to 0. So here we have a trinomial, okay, where is a trigonometric equation. Again, I have to find the values of x. My x is my angle, and it's going to be between 0 and 2 pi. All right, a full cycle. So the first thing is first, I noted that this is a trinomial, so in my case, I will have to factor. So this is a simple trick that I'm going to say, all right, hold on. So I don't have to deal with the signs. I'm going to call sine of x equals anything. Let's call that y, for example. Okay, this is going to be a substitution trick that I'm going to use. So I don't want to deal with sine. I would just want to call. So in this case, if I say that my sine of x is equal to y, then I'm going to replace here in the top. So 2 sine square of x is going to be 2y squared plus sine of x, sine of x is y, minus 1 equals 0. So sometimes it's easier to see this as a trinomial, look in algebra, regular algebra, okay? And then I have this trinomial, that means I have to factor it. Okay, how do I factor this trinomial? I use grouping. In order for me to use grouping to factor this trinomial, I need to get 4 terms. Okay, right now I have 1, 2, and 3 terms. I need 4. All right, so let's get this into 4 terms. How do I start? I multiply my leading coefficient times my constant. 2 times negative 1 is going to give me negative 2, I'm sorry. So my product for this has to give me negative 2. My sum is always the value in front of the y, which in this case is 1. So I'm looking for 2 numbers that gives me negative 2, but the same 2 numbers give me positive 1. My answers are 2 times negative 1. 2 times negative 1 is negative 2, but 2 minus 1 is 1. So I found my 2 numbers. So these are the 2 values I'm going to use. What do I use these values for? To break the middle value here. So let me explain. So I'll have 2y squared plus y minus 1 equals 0. The value of 2 and negative 1, I'm going to use it to break the y. Technically, I have 1y. That 1y, I'll break it 2y minus 1y. 2 minus 1 is 1. Okay, I'll bring the first term and I'll bring the last term. So 2y squared plus 2y, and then at the end is minus 1. Now that original trinomial I have with 4 terms. Now I'm able to use grouping to solve this. First 2, last 2. On each parenthesis, I'm going to use greatest common factor. My common factor between the 2y squared and 2y is going to give 2y. That's my common factor. Open parenthesis, 2y squared divided by 2y is y, plus 2y divided by 2y is 1. Okay, and I did my GCF on the first parenthesis. Next, common factor, my greatest common factor on my second parenthesis. I see that I have a minus and a minus, so that's a common factor. Other than that, the 1. Nothing else. So now, open parenthesis, take the first term, and I have negative 1y divided by negative 1. It will give me y. And now, negative 1 divided by negative 1, it will give me positive 1. When I'm doing grouping, as soon as I do the greatest common factor, these parentheses have to be the same. When the parentheses are the same, technically I'm doing another greatest common factor, which is bringing that parenthesis as a common factor, open a parenthesis, and whatever's on the outside of those 2 parentheses will come to my second parenthesis. And that's how I factor that trinomial, by grouping. Once I have this, every factor, let me write it here, oops, okay. every factor has to be equal to 0, because remember, we're solving for the value. So I have 1 minus 1 times 2y minus 1 equals 0. Okay, so each parenthesis, each factor equal to 0. The second, 2y minus 1 equal to 0. Solve for y. Okay, let's solve for y. So let's solve for y for the first one. Plus 1 plus 1. They cancel out. 0 plus 1 is 1. Now I solve for y, finally. So once I have this, I go back to my original substitution. So sine of x equals y equals 1, therefore sine of x equals 1. And I have solved for x. Okay, I need to find the value of my angle. So hold on to that. Let's do the right side. I need to solve for y as well. Plus 1 plus 1. So I have 2y equals 1. Divided by 2 divided by 2. And y equals to 1/2. Oops, yes. The y is by itself. I'll bring my substitution again. That means sine of x equals 1/2. My signs are by itself. Now what are the angles? Okay, so here we go. First of all, sine of x equals 1. So on my unit circle, okay, let's call that a circle. I'm sorry about that. What angle is x where my sine is equals to 1? Unit circle, this is 1, 0. Remember, your sine is the y value. This is 0, 1. You see this? Your sine is 1. That's what I'm looking for. What angle is this? 90, which is pi over 2. So therefore my angle x is pi over 2, and I have one of the answers already. Okay, we got to do the same thing for the second one, where my sine is equal to 1/2. Okay, 1/2, I got to go back to my special right triangles. This is a 30, 60, 90 triangle. Okay, opposite to the 30 is 1/2. So sine is opposite. Therefore my angle is going to be 30. In terms of pi, is pi divided by 6. Okay, so pi divided by 6, my sine is positive in Q1 and Q2. So my reference angle, Q1, this is pi over 6, and Q2, I'm sorry, this is pi over 6. So this is my reference angle. So the angle that I'm looking for is not the reference angle. It's from the origin all the way to here. All right? The whole thing is pi, which is 6 pi over 6. My reference angle is 1 pi over 6. Therefore, the remaining is 5 pi over 6. The remaining angle. That's 5, and then 1 is 6. So let's go. X is equal to pi over 6 in my Q1, pi over 6 in Q1, and in Q2 is going to be 5 pi over 6. Alright, so stay tuned. We're going to work on another video with more problems. There's a lot of problems that we can solve. Thank you for watching.